The streets of Beijing hosted the E-Town Humanoid Robot Half Marathon. Dozens of robots lined up to run a 13-mile course. What is surprising isn't that a humanoid robot ran a half marathon faster than a human, nor the sheer weirdness of the event itself. It is the blistering speed of development over the past year. Last year, the winner's time was 2 hours and 40 minutes. This year, it dropped to just 50 minutes. Last year, out of 21 participants, only 6 crossed the finish line, and they relied heavily on remote control. This year, over 300 robots participated, and 40% of them ran completely autonomously. China is completely all in on robotics, and it is moving faster than anyone ever anticipated. What exactly is going on with China and its robots? According to the International Federation of Robotics, China accounts for more than half of all global industrial robot installations. In 2015, Beijing launched its Made in China 2025 strategy. Made in China 2025 exemplifies how China's industrial strategy is a comprehensive mobilization of state resources, private enterprise, and national priorities that has reshaped global technology competition, prioritizing robotics as a core national interest. As a result, Chinese factories are rapidly outpacing the West in terms of robot density, the ratio of robots to human workers. Now, under China's 15th five-year plan, spanning 2026 to 2030, Beijing has officially designated physical robotics as a foundational pillar of national development. This isn't just about automated factories anymore. This is a state-enforced shift away from simple mechanical arms toward high-end intelligent systems integrated with cognitive AI. So, why is China so obsessed with robots? In a word, survival. The country is staring down a rapidly shrinking domestic workforce, soaring labor costs, and the urgent need to maintain its industrial dominance. Having a plan is one thing. Execution is another. And China is doing both. In just 1 year, Chinese suppliers have aggressively driven down the bill of materials for humanoid robots by a staggering 40%. China's rapid scaling is supported by a highly integrated hardware supply chain. This massive cost reduction allows companies like Unitree to export advanced models at price points Western startups simply cannot compete with. When NVIDIA's Jensen Huang announced their cutting-edge Project Groot reference humanoid platform for AI developers, the actual physical body they chose to run it on was a Chinese-manufactured Unitree chassis. Even Elon Musk's ambitious Tesla Optimus program is deeply tied to Chinese supply chains. This reality became painfully clear when China tightened export restrictions on medium and heavy rare earth elements. China is replicating the exact state-level subsidy playbook it used to dominate the global EV market, this time applying it to win the robotics race. In 2020, annual electric vehicle sales in China hovered just under the 1 million mark. By 2024, these Chinese manufacturers had secured a massive chunk of the market, dominating their home turf while aggressively expanding into several emerging economies. This was possible due to massive capital injections, localized manufacturing hubs, and specialized engineering pipelines, fueled by an education system that prioritizes hyper-fast AI and robotics adoption. So, where is the US in this robotics race? While America may be falling behind on physical hardware, it currently still holds a dominant lead in the brain category. Every advanced robot requires 3 core elements to function: the brain, the AI and cognitive compute, the inputs, sensors and cameras, and the outputs, actuators, motors, and physical limbs. American tech firms lead the world in foundational AI models, and NVIDIA dominates the virtual physics simulators used to train these systems. But simply having the best computer chips won't inherently win the robotics race. Why? Because of the lack of physical data. Large language models like ChatGPT scaled rapidly because they could scrape trillions of words of readily available text from the internet. But you cannot scrape physical interaction data from a web page. To make a robot seamlessly operate a forklift, fold laundry, or navigate a chaotic factory floor, you need real-world physical data. China is bypassing this bottleneck entirely by deploying thousands of cheap robots directly into active workspaces. They are letting their machines make mistakes, fail, and feed that data right back into a massive optimization loop. Why can't the US do the same? One of the primary reasons is the US government. The United States is watching China's rapid expansion with severe national security anxiety. In modern warfare, nations are becoming increasingly reliant on private tech companies. Weapons systems are heavily networked, cloud-dependent, and capital-intensive. In this environment, Chinese robots are viewed as a massive liability. Critics of Chinese robotics point out that under China's strict military-civil fusion mandate, commercial robotics manufacturers are legally obligated to share their telemetry and user data with state defense programs. In response, U.S. lawmakers introduced the GUARD Act. This legislation forces national security agencies to review foreign robots. If a device is flagged as an unacceptable security risk, it is placed on the FCC's covered list, effectively banning it from operating on American networks. While this digital firewall may protect data, it severely cripples American innovation. Aggressive tariffs make importing cheap, highly capable Chinese components incredibly expensive. Deprived of affordable hardware, U.S. developers are forced to build their own custom physical bodies from scratch, driving up production costs and delaying their ability to gather the physical training data they desperately need. Compounding the problem is America's permission-first regulatory environment. Furthermore, strict union agreements in major shipping hubs and automotive manufacturing plants actively limit the adoption of automated labor. China wants cutting-edge chips to accelerate its robots' brains, while the US needs hardware from China to stay in the race. For both superpowers, the ultimate risk lies in the escalating geopolitical narratives rather than the technology itself. Beyond the question of who wins, there is also the question of what the true reward of winning actually is. Despite viral videos of robots performing backflips and outrunning humans, many critics say that we have yet to see them working autonomously or performing actual human labor. The vast majority of commercial humanoids shipped today remain restricted to research labs or corporate display lobbies. This remains an unsolved problem for both nations. However, this follows a pattern we have seen before. When AI first learned to distinguish between a chihuahua and a blueberry muffin, people didn't know what the practical use would be. But looking back now, that exact foundation has evolved into the revolutionary AI we see today.